is pop that open. You already did this. So you knew what to do, you just didn't want to share with me. Good job. Way to go. Okay. So you know this is 40, so you plug in 40 there and there, and I get that the f at 40 is equal to 20. We all agree that's the highest spot. How much calculus did we use? None at all. Which is disturbing. Let me ask a physics student. Who's a physics? Sachs was a physics student. What's the velocity in the upwards direction at the highest spot? Zero. Velocity. This is the velocity equation, is it not? Couldn't I take the derivative? Okay. Let me ask this to a non-physics student. Mr. Manuelos, what's the slope at the top of that thing?
The slope?
Slope.
Zero.
Zero. Couldn't I have found where the slope is? Zero. And how would I find the slope? Derivative. I would take this original function. I go f prime of x is equal to negative 1 over 40 x plus 1. I want to find where that's equal to 0, correct? Oh, I'm pausing here. You with me?
Yeah.
So it equals 0. I get 0 equals 1 over 40 negative x plus 1. Move the 1 over, get negative 1 equals negative 1 over 40x. I get x equals 40. That tells me where the maximum was. And then how would I find what it is? I'll use the Kirkland secret method that you didn't want to share. I plug it back in the original equation to see how high it was, wouldn't I?
Yeah.
That make sense?
Yeah.
So if I want to find the maximum, that happens where the slope is
Or zero.
0. Imagine any function I want to draw. I go, woo! Oh, that's terrible. Okay, let's try this. Woo! Where the maximum is going to appear? Where the slope is 0. Yes, man. Oh, yes, sir. You're good? Make sense? All right, excellent. So now we're going to define these maximum minimums. The maximum minimums of the group we're going to call extrema, of which there are going to be 4 flavors of extremas. We plugged in the 40, remember? We did it before.
It was 20, right?
Yeah. We just found a whole different way to find what the x value is so I could figure out what the y value is, right? That's all we did. You guys all knew it was 40. Some of you didn't want to share that, but you all knew it was at 40. If you all knew it was 40, you plugged in 40, you got 20. I showed you the official calculus way to find that it's 40 so that you can make it 20. That make sense?
Yeah.
Okay. So this gives you the x value. So extremas. There are going to be 4 flavors of extremas. Yes, 4. We are going to have absolute maximums. That would be the highest point. Absolute maximum. The lowest point is going to be the absolute minimum. But we have these cute little ones in the middle. See that one right there? And what are we going to call him? Or her? What are we going to call it? Because we're not judging anymore. What are we going to call it? We're going to call it a relative, or local maximum. relative or local maximum, which means compared to the two directions, left and right, it's a maximum. But compared to the whole entire graph, maybe not so much. Make sense? All right. But what are the slopes for relative maximums and minimums? Mr. Strauss?
Slopes, 0.
0. Okay? All right. Now, we're going to mess with you a little bit. Are you ready for a little bit of messing with you? We've just established you can find extrema by finding where the slope is what? 0. There are other places extrema can hide. What do you mean by that? Well, what if I have a graph that does this? Whee! Oh, yeah! Is the slope there necessarily 0? Not necessarily. In fact, it might be undefined. So that can lead to a maximum, can it not, or a minimum? So where the derivative is 0 is one place where you could have an extrema. Where it says the derivatives do not exist. Fix that. That's not right. It's where oh, wait, that could be true too. Hold on. You're right. That's not what I meant to do. A boundary. Let's call this a boundary. Boundary. This could be a maximum. This could be a minimum, right? Where the function is undefined, or the two endpoints, the function is undefined, or the two endpoints can also be extremas. Maximum, minimum. Does that make sense? I'm doing the little things in the bottom. Rachel's in the right spot. I'm bad with us. You with me? And then the third one is what I used to call pointy points, but I said we're going to discuss it later. It's later. And that is where the slope does something awful. You ready? Where the slope is undefined. It goes up like this. Whee! And then bam! What's the derivative at the top? I don't know. It's undefined. What do you mean? Left or right? I can't tell. It's a pointy point. If it's a pointy point, that could still be a max or minimum, right? So where the derivative is undefined, it's also a place you could have extrema.
What was the second one?
The second one was endpoints or boundaries. Okay? It's places where the graph stops. That can be a max or a minimum. Okay? All right, so the strategy going forward is going to be this. You are going to take the derivative, find places where it's undefined or where it is what? 0. You're going to take the endpoints, the starting point and the last point. You're going to add them to the list. You're going to make a list of points that are possible maximums. This list, by the way, has a name. It's called critical points. If AP Central ever asks you to find a maximum or minimum and you don't list critical points, I guarantee you lost a point. Guaranteed. They expect to see a list. Write down a list of critical points. If you don't, I don't care if you get the problem right, you're still not going to get credit for it because you didn't check all the critical points. Okay? So you write a list of points. What are the points going to contain? Any place where the slope is 0, slope's undefined. Or endpoints. The starting point, the end point, and any undefined point where the graph does something stupid in the middle. Those are all called critical points, and they all need to be checked. Then how are you going to check them? See whether they're the maximum or minimums. Plug them back in the original function. If they're higher than the other ones, they're a maximum. If they're lower, they're a minimum, right? Just that simple. All right, flip this over. Let's see if we can do the problem on the back. I don't know. I don't remember it very well. You know what? I don't like that top problem. Let's just cross that one out. Although, no, we already save it for later. Save that for later. I want you to find the extrema for f of x equals x to the third plus 2x squared plus 1. I'm going to do the middle problem first. It's easier, and it would be a better example problem because you guys don't like trig.